Hello everyone. On behalf of SNS College of Technology, I would like to extend a warm welcome to all. Thank you all for being here for today's webinar. It's a great pleasure for me to introduce our speaker, Dr.S.Sabarathnam sir, who is going to talk to us about applications of mathematics in engineering. Our speaker is currently working as a postdoctoral research fellow at the Modelage Project in Biomedical Signal Interpretation and Computational Simulation Group, 13A, Aragon Institute of Engineering Research, University of Zaragoza, Spain. He is also a prestigious author of a number of papers. We are grateful for your presence among us today, sir. And now we'll hand over the session to our speaker.
Good morning to everyone. So I hope I am audible. First of all, I would like to thank the organizer for giving me the opportunity to present the important application of mathematics. So I would like to share first and then we'll start. I think everyone see my screen, right? Okay, perfect. So today I'm going to talk about some important applications of mathematics in science and engineering. Actually, my background is physics, but last 6-7 years I'm doing the mathematical modeling. So as well as I'm doing the nonlinear dynamics too. So let's start. This is my content of presentation. So first of all, I am going to give the short notes why the mathematics is important and why we are need to study the mathematics to improve our life as well as our career, etc. After that, I just explain some quick history about the mathematics, some important milestones in the century, as well as some important persons who identified some novel phenomenon in mathematics. Then I move on to the application sections. I am just give some important field when which and when the mathematics are using, which is science and engineering fields. After that, I would like to give some examples. We can see how the mathematics can use to identify the problem as well as how to solve the problem. After that, I just explain some scope and future. Finally, I conclude my talk. So why mathematics? So in the first half century, there has been great increase in the interest and the importance of the mathematicians in our society because of the globalizations. So in the previous historical time, so all the mathematicians are separated from the science and art background, but nowadays all are come into the mathematicians everywhere, means all they are doing mathematical modeling, many type of mathematical calculation in all the fields. So the need of mathematician is unique now. So for example, some engineering and technology related field, they are requiring the mathematicians to solve some engineers have some expertise in mathematics. They are doing some good maths. Then they're Delhi actually. One train starting from Chennai and another train starting from Madurai. So they are approaching the same destination like Delhi, but they are starting in the different distance, like Chennai train starting at 50 miles per hour, and Madurai train starting 1850 miles away from Delhi, as well as 40 miles per hour. So someone asked which train goes first, what is the time difference between them. So this kind of small question someone asked, so the mathematician can easily solve it. uh, this kind of small problem, we don't need the core mathematician. We can say, like, we can just divided by the distance, divided by the speed, as well as we can find the hour, and we can subtract the hour, and we can find the difference between the trains which are reaching from the destination. As well as someone asked what is the radius of the circle with circumference of 2 pi. So this kind of small questions arising around us. So someone have good understanding. So we should understand the mathematical concept as well. Then only we can overcome many problem arising around us, as well as our career also. So the mathematical studying the mathematics can be used in the following ways: some funny ways, as well as some career ways, as well as some impact ways. So learning maths, first of all, it is a good for your brain to take the decision, as well as making improve your skills. And it helps to tell the time. This it's a funny importance, because most of the students, school students, around 7 years, 8 years old, even in India, 70% of students, they didn't know how to tell time, because they didn't aware of mathematics. So this you can understand the importance of mathematics. So we have to learn mathematics from the beginning, then we can improve our life easily. So the mathematics helps you with your financial, in improving your finance status, as well as you making you a good cook, because in the cooking department we have to do many calculations, how much time it's boiling. So likewise, so you can understand this is the importance of the mathematics in this field, as well as the mathematics give the good problem solving skill. This is a very outstanding skills some everyone should have, as well as it improving your career as well. You understand the world better, you must learn the mathematics. So once you learn the mathematics, then maths make you more popular. So always math can help you shop for good sale. So once you know the reduction and um, this percentage calculation, then you can buy a good sale, I mean good things in a cheap price. So um, so at the end, maths is a universal language. It exists everywhere in the science and engineering. So let's move on to the history section. So this is a Mayan numeral scheme. So this having a separate histories. Someone want to know about the Mayan calendars and Mayan numerals, then you can search if you are rich. So the history, the age of the mathematics is almost equal to the humanity ages. So from the prehistoric time, so I am talking about the ancient time, the mathematics evolved starting from the numerals. So many regions in the world, they are using the different form of numerals, as well as they are using some logic, and they are using some symbols likewise. So in this table, we can see the European, this is a standard one in the world. So as well as Arabic and Indic numerals, as well as Eastern Arabic Indic numerals, you can see there is a different form of numerals they are using. As well as Tamil, we have a numerals, but nowadays no one use this Tamil numerals. Okay, this is evolution of numerals in the ancient history of mathematics, as well as uh, this table showing the numerals evolving, particularly in India, in different empire level in the history. You can see from Asoka to Devanagari Pasha, as well as the Gupta schemes. We can see the numerals evolution. So This is an ancient time and prehistoric mathematics. So this is we have only a limited evidence. People how the ancient means prehistoric people understand the numbers as well as mathematics. They are writing the numerals in the bones of animals as well as some caves like one, two, and many. The ancient people actually they are knowing only the one, two, and many. They even didn't know about larger than two. So this evidence we got from the caves as well as the old statues. And let's start with the 16th century of mathematics. So we can say 16th century is the beginning of the mathematics evaluations. So in this 16th century, there are numerous invention and discoveries about some simples and some functions. Even Fibonacci series invented in 1202. So we can see the invention here. I am giving the name as well as which numerals and functions they are invented. So in the ancient means the 16th century, people only aware of science and arts. So in the great work of Leonardo da Vinci, you can see many films. He do some mathematical calculation to develop some creatures like solar clock and gravitational clock. Likewise, this kind of mathematical calculation he do. After that, people aware who some mathematical background and the mathematical importance they come to know in the 16th century as well. So in the 17th century of mathematics, we can see say unprecedented explosion in the mathematics as well as scientific ideas. So actually evolves from the Europe. The important mathematicians in this era, we can say Galileo as well as Kepler. So they are invented as they are doing the research about the solar system, and they are um, giving the wonderful law that is Kepler law. We can see in the right side, the Czech Republic released the coin like 200 knot for the remembrance of the invention in the Kepler laws of planetary motions. And even the 17th century, the important invention like logarithmic is invented by John Napier as well. It actually the important means logarithmic. We know it is it is very useful tool to make the calculation very easily. Actually, this is used in all the fields. You can say. So in the 18th century of mathematics, we can say this is the evolution of calculus. So the important mathematician we can see Newton and Leibniz. They are making some important calculus in this century, and even this century, the researcher as well as mathematician, they are start using the functions. Function is function means you can see here in the plot this kind of functions they are start using in the 18th century. So after that in the 19th century, we can say it's a fight between the two group like France and Germany. They are fight between them with a mathematical concept, which one is right. They are trying to fight likewise. So we can say in the complexity of the mathematical concept. But in this time, there are a huge amount of mathematical invention as well as mathematical laws can be generated. Uh, um, so in this century, the important application like Fourier series has been invented. We can see the portrait of Fourier. As well as in this century, they are start using the geometry as well, means hyperbolic geometry, Euclidean geometry, elliptic geometry. This kind of geometry, 19th century people know. So in the 20th century, there are many inventions, but we just focus on our Indian mathematician, like self-taught Indian mathematical genius, um, Srinivasa Ramanujan. So actually, Srinivasa Ramanujan identified by the great mathematician and Hardy. So you can see the film. I think the man who knew the infinity film. You can see the whole history how Srinivasa Ramanujan has become a great mathematician around the world. How he calculated the things. So all are very well visualized by the movie. You can see the man who knew infinity. So he also gives some important contribution in the mathematics, like um, formulation of some mathematical concepts. And let's talk about the Indian mathematical history. There are we are the inventor of the numeral zero. Actually, the invention itself, we have a contradiction, like which century we are invented the zero. So some people are saying it is invented in 17th century by Brahmagupta, and some people are saying it's evolving 19th century. We can see the Gwalior temple as well. So there are many contradictions, but we are the inventor of zero, as well as some Indian old temples. They mentioned, like you can see the 400 is to 1. They are also doing the research in the astronomy by using mathematical concepts. So they are making 400 is to 1. This means the distance between sun and moon is equal to the 400 times of this distance. So they are mentioned like 400 is to 1. As well as some caves, we can find this big circle inside the small circle. This is the indication of zero. Okay, let's stop the history, because there are unlimited history in every field. So if you want, you can see, as well as mathematical branches like differential equation, partial differential equation, non-linear differential equation, stochastical differential equation, as well as algebra, calculus, trigonometry, etc. So have their own beautiful history. If you want, you can go to the website and you can learn and enjoy. Okay, let's move to the application section. Actually, mathematics can be used in science and engineering in the same level. So before we are entering the application, we have to know about the applied mathematics. So this is a small divergence from the core mathematicians as well as the engineers. So engineers actually know only the applied mathematics because they are learning in part of their engineering courses. So applied mathematics, they have to learn some mathematical concept and they have to apply it in various fields which their engineering belongs to, just such as which they are belongs to some different engineering field. So they must use all the concept whatever they need. So actually, applied mathematics is the application of mathematical method by different field. We can see it is used for physics and medicine, biology, business, computer science, as well as the industry. Let's talk about a little bit about the application of mathematics in engineering field. So I just give some few example regarding the application of the engineering. So we can use the mathematical concept like calculus, trigonometry, differential equation, numerical analysis in the various field of engineering department. Like for civil engineers or mechanical engineers, they have got the job in the building bridges, construction side, automotive design, robotics, even many other entertainment field, as well as some core IT field. They are using many variety of mathematical concept in their during their engineering studies. Um, for example, making the building fridge, we will see in 1998, the Tacoma Narrow Bridge is collapsed. Actually, it is people are arguing this is a problem in the engineering modeling, but engineers they are analyzing the full bridge, why it is happening and why this dancing the fridge. So they analyzed through the mathematical concept, like they are making the complete fridge model by using finite element method as well as finite differential equations in the two different categories. Like one group they are using to measure the errors, how it is become the crash happen. They are using the finite element. Some people they are model the full fridge dynamics by using the differential as well as partial equations. So after some times it start collapse. So this is the mathematical model of FEM actually. At this time, the collapse of this fridge, people are saying that this is the effect of resonance. People are walking together, so the resonance is appear and the bridge is destroyed. But this is not the case. The engineers have identified through the mathematical model this fridge is fell down due to the aeroelastic flicker effect through this vortex dynamics analysis. So this is completely understood by the mathematical concept as well as the mathematical modeling. So nowadays you can see we can construct any length of many bridges who have the length more than 1 kilometer, 1.5 kilometer. You can see this is the basic thing the engineers have um, analyzed the fridge dynamics through these mathematical concepts. So, and in so, we can read many mathematical concepts during our mathematical courses when you are in the first year and second year, as well as you have seen many beam equations by using the division as well as differential equations. So this kind of equation you can see the direct applications in your last year PhD, last year engineering, as well as when you are going to the job in the skyscraper builders, like in the Gulf countries. So most engineers are want to go. So through this mathematical concept, they are constructing a very huge skyscrapers that can withstand to storm as well as earthquakes and many external disturbances. So these phenomena, they are having the complete mathematical model of this building structure, as well as they are applying some external errors, like they are giving some vibration, as well as they are giving too much wind flow. They have understand the model first, and then they start doing the real time work. So in the application of mathematics, like in the medicine and health field, have the significant importance. We can see for this medicine and health field, there are two types of mathematical concept can be used. Like one from mathematical modeling, as well as second one from the signal processing. So in the signal processing, we can use many statistical measures, numerical analysis, many things. Like if you want to check the MRI, so we have to take the time series of our brain, like alpha wave. Then we have to analyze through some statistical measure as well as mathematical modeling. So in the epidemic analysis, I think this picture everyone know. In the epidemic analysis, nowadays researchers are very much interested to solve this problem, to construct a mathematical model first. So they have an extract mathematical model, and they are giving some foreign cells with the model, and they understand how the disease or the pandemic evolved from the group as well as in our body. Then they give the suggestions to the medical field, means doctors as well as some researchers. So this kind of research study, the mathematical concept as well as mathematical model is the great importance and emergence of is a very needy topic. As well as the mathematical concept can be used in neurology, in we can understand the crowd control, as well as pharmacy and medicines. They are making the vaccine structure as well as antibiotics. They use the mathematical concepts. As well as we can understand the population dynamics through the simple mathematical equation we can see in the right side. Xn plus 1 is equal to r xn 1 minus xn. This is a famous equation which is called the logistic map. This map we can understand the population dynamics, how the population evolves with time. Actually, this equation we can call it as a difference equation. So let's see, from here to here there are one group of people. After that they are generate the another group, so it becomes two. The two groups can generate another two groups and another two groups, so it evolves like one to one. So we can call it as this big this entire picture called bifurcation. So this kind of simple mathematical equation can give the how population dynamics can evolve with time. We can understand how much population in after 15 years, 20 years, like this. So there are many mathematical model regarding this population dynamics too. So you can learn in the future. As well as the application of mathematics like in the finance and business have the significant importance. Likewise, if you have a good knowledge in the statistical as well as numerical concept, then you must a needy person in the financial and banking department. So once you are doing the engineering, so we have to learn like this kind of statistical measures and this banking concept. If you are wish, actually this mathematical concept already you have learned while you are doing the first year and second year. So this is very useful through this particular field of branches of the mathematics. Like this field can help to understand the insurance as well as how the fraud detection can be happen in the internet. So nowadays it's increasing, as well as we can use this statistical as well as numerical concept by in the data analysis field. This is also an emerging field in the recent years. As well as we can find the pricing strategies as well as game theory, loan and interest. So this kind of finance and business, if you are know these particular branches of mathematics, you can predict the future of this field also. So how much sensex is going to increase or decrease. Likewise, you can find the good math. If you are a good mathematician, then you can find the exact future in this particular field. So this application of mathematics, in science and nature, have the broad application. If most of the mathematical calculation in this field by doing the data analysis. So if we have a data for last 100 years or 200 years in the in glacier melting, cosmology, as well as this wildlife modeling, we can understand how it's going to happen in the future. So through this some small mathematical model. As well as we need to understand this type of data through some particular statistical as well as differential equation and decision making skills. This mathematical concept can help you to understand the carbon dating also. We can see the equation T is equal to 1 divided by lambda logarithmic of 1 plus T divided by P. So in the letter, we can see T and P and lambda T. Uh, uh, every term have its own explanations. So through this explanation, we could shuffle on them and make the model. Through this model, we put the value and we come to know the age of the statue or anything. We can calculate the age. This is a great concept in the field of carbon dating. So the application of mathematics also importance in the sports field also. We can make the fine strategy using this mathematical concept like football scoring and swimming and this skateboard technique. Everywhere the mathematical concept can be used how to predict the errors as well as to achieve more. So you can see the Usain Bolt last two match, I think. he got a second prize. So the first prize person actually tell this truth. They analyze completely the dynamics of the Usain Bolt, how much stamina he have, many parameters they analyze and they improve itself, and they got the first prize. So likewise, the mathematical concept can be used in the sport in the most important way. As well as application of mathematics, we can use in the media also by using various branches of the mathematics, like reading the CDs and DVDs and digital musics, making the music, as well as movie graphics. Like there are many graphic software available in the internet, as well as they are making the movie and short films. They are using many graphic software. These software are actually run in the background of mathematical and physics concepts. As well as we can use the mathematical concept by polling and voting, as well as music shuffling, how much time we need the shuffling. This kind of small mathematics we can use in this music media industry. As well as we can use the mathematics concept in the technology in the great manner. So in the technology, the mathematical concept can be used in the broad range, from weather dynamics to navigation dynamics. So let's talk about the predicting the weather. It's an important and a very emergence in the current scenario, because the weather changes drastically nowadays due to the global warming as well. So we need an exact mathematical model to understand the weather dynamics. For that, engineers as well as the researcher are making the mathematical model. They are combining together and they understand the rotational as well as how it is moving. Likewise, they have found the equilibrium, the small concept they are shuffled together and make the exact mathematical model. You can, if you are having an interest in weather predicting model, you can see the Lorentz system. Lorentz system can be is a very simple model to understand the weather dynamics. So this is the mathematical modeling by using a three-dimensional differential equations. So it's a very simple equation you can see, and you have a great application to understand the weather dynamics, as well as the mathematical concept can be used in internet phones. um, yeah, this reading and CDs and DVDs already we are discussed. And in cryptography, mathematicians is concept is very important, as well as the satellite navigation and digital musics, breaking the enigma, and search engines like Google and many search engines. They need the mathematic means they are need the engineers who have the great mathematical skills. So they need to make the calculation, like how to avoid the um, traffic when they are come to the one website in a particular time in large amount of people. This kind of small strategies, they need the mathematician to solve the problem. So as well as computer can be used by the you can see this is used by the binary numbers. So computer can only know 0 and 1. Through this combination, we can use anywhere. Computer have the different era, you can say. Even mathematical concept, we can see the application in the navigation field itself. As well as the mathematical concept, we can use speech recognition, public transportation, like air traffic control is another emerging field nowadays. So this kind of air traffic control, the need of mathematical people is very important to solve the problem, because this kind of airport traffic, they yes, small phenomena can cause the collapse the entire network. So we have a sharp and very crystal clear mathematical thing in the air traffic control. So we can use the mathematical concept as well, computer circuits and artificial intelligence, image compressions, measuring time. So everywhere the mathematics can be used. So let's see the applications of mathematics in different branches, as well as which branch they are dominantly used by the field. Let's see, algebra can be used in computer science, cryptology, scheduling the tasks on processor in a heterogeneous multiprocessors computing network, as well as alteration of pattern pieces or precise seam alignment and the crystal symmetry. We can see there are a lot of applications in the algebra field, as well as differential equations like ordinary differential equation and partial differential, stochastic differential equation, as well as the Fourier analysis can be used in many field. Like most of the physics and engineering field have this must need this kind of to understand the strategies or to making this phenomenon, to making the mathematical model. They need the differential equations in different forms, as well as this ODE PD can be used in sound wave to identify the sound waves in air, crystal growth field, curricular modeling, and many field you can see in the list. Even they are making the modeling like aircraft landing and how much length the aircraft should need. This kind of small calculation also they need the differential equations. Actually, in the listed field, they only use different. They didn't use only differential equations. Actually, they are using the another branches also, but dominant in the field is shown in here. So, and this same, the differential equation we can use to find the underwater acoustics, signal processing, and nonlinear dynamics. So, actually, I am belonging to the nonlinear dynamics background. So, and we can use this ODPD concept in waves in composite media, immunoassay, radio interferometry, Freemasons in nuclear physics. So likewise, it's shown in the list is very long, so you can see the importance of the differential equation. And the another branches like differential and computational geometry can be used in the field of computer aided design of mechanical parts and assemblies and terrain modeling. So there are many modeling like a small portion we need the modeling like rabbit and the terrain modeling, the parking. So we the small kind of terrain we can use in this differential and computational geometry. So this will all these branches can be used in color balancing, photographic system, optics for designing a reflector, cryptology, airflow patterns, many fields. And another important branches in the mathematics, we can say probability and statistics. So one could familiar means one engineer and familiar in the probability and statistics. So this person can be a very needy person in the future because they are going to predict the future of this field. So these probability and statistical branches uh, we can use by making the insurance risk and this banking data, as well as they are analyzing the sensors and large scale physical simulations, speech recognition, signal processing. So they are many field. They are using the probability and statistics concepts. So this is a very important branch in mathematics for predicting future as well. So then another important branches in the mathematics like numerical analysis can also give the future predictions in the following field like estimation of ocean currents. Not only the ocean current, they predict how the hurricane moves and where they are going to affect. So this kind of weather dynamics also we can estimate through the numerical analysis. So this numerical analysis can do only the exact mathematical modeling by using ODE and PDEs. Moreover, this numerical analysis, we can use many algorithms like Euler algorithm, Range-Kut algorithm. Many algorithm is also there. So, and many processes like Gram-Smith reorthogonalization. So, this kind of orthogonalization kind of numerical analysis also we can use to predict the future of this following field. And another important field is operations, research and optimization. This is very important to predict how it evolves with the group dynamics, how they are going to um, use means how they are going to predict in the distributions. Likewise, this kind of calculation we are using this field. We can find the network formulation of cut order planning problem and motion of a space vehicle, radio interferometry, and many field we can see in the slide. So it has been a wide application. Okay, let's start some simple example. Finite element method. Actually, finite element method is a very important and emerging research area as well in the recent times. So, I personally asked engineer who they are studying in the first year or second year. So they just learn some basic concept about this finite element analysis and finite element method as well. So this is very important concept you can understand. This is completely a problem solving strategy to in maths and engineering field. So it gives the exact analytical solutions more clear, and it is understand the basic physical behavior of a complex object, like how the object is strength and how the heat transfer through this full body, and you can see the fluid flow, how it is flow is happening. Many realistic phenomenon you can see through this FEA mathematical modeling. So let's see. Uh, so you can see the object. So this object can be differentiated in the three elements. So these elements is coming from the finite element. You can say this is the element. After that, this element can be differentiated by nodes. So through this node, you can choose the particular place in the object. Let's see if some node have less stress and less strain, and if some node have a higher stress and higher strain. So this kind of physical phenomenon we have understand through this node. After the node strategy, we can construct a 1D, 2D, 3D structures like 1D beam and 2D plates, like in the gear shaft you can um, create. So this 3D model, you can see the small part which belongs to the engine. It is belongs to the car engine actually. So you can see this element as well, elements, how many elements are combined together, as well as we can see the nodes. So in each node have the different colors which represent the different strain and stretch, as well as the different temperature we could plot. So through this color recognition, we can solve many issues, like we can find the irregular boundaries, we can solve the load, we can find the how much load it takes maximum. This kind of behavior we can understand through this finite element method modeling, as well as we can find the boundary conditions, variable element size, EC modification, and we understand the full dynamics of the these 3D systems by using the finite element method, and various nonlinear problems arising due to the instrument non-linearity, the design, the various mathematical functions like x squared, x cube, like this kind of non-linearity who they are arising from this mathematical model. So we have to learn those problem also. Then we can solve with these non-linear strategies. So this finite element method we have a wide applications. So nowadays people are using different field, like mechanical field. In the construction field, you can see in the bottom there is small roof which have a different stress and strain. So this color code represent different physical phenomena, like say stress, strain, load, temperature. So we can see many strategy we could apply through this FEM. So these FEM also, nowadays they are using to construct the real human behavior, like heart, kidneys. So they are using to construct FEM nowadays. So in FEM also we can use to detect the problem arising in the ICs. So you can see this is the MIMS, micro electromechanical system resonator. This combination of resonator we can construct the ICs. So this resonator, a different color indicating the different level of temperature arising. So we can come to the conclusion from this example. So which portion we need to give the importance more. So to avoid the break of ICs and break the electronic instruments. So I think I give some importance of the mathematics and why we are studying the mathematical concept. And I also explain some important milestone in the history of the mathematical eras. And I explain some application of mathematics in the science and engineering field. As well as I just give the mathematical modeling like the finite element method through some analysis. So the scope and future, let's say if you are engineer, you are doing the engineer like first year, second year, you should learn some softwares by using direct mathematics like MATLAB, Mathematica, R, Python. So this kind of software you just learn in by side. This is a very helpful and very informative softwares. So you could use in the future once you are got the job. You probably use in this belonging softwares. So you have to write a code in R software. Kind of this kind of software you should understand before. So okay, let's thank the organizer once more, and I would like acknowledge my friend Ms. Jagadishwari who reviewed these full slides and give the suggestions. So thank you very much. Now I am going to hand over the session to the organizer.
Dear participants who are all attending this webinar, please go through the chat box and kindly fill the feedback link so that you will all receive e-certificates. And this is the time to thank our chief guest. A very special thanks to you, sir, Dr.S.Sabarathnam, postdoctorate research fellow, who spared his time and his busy schedule for us to share some valuable points about applications of mathematics in engineering. It is very useful to us, sir. Thank you so much, sir.
Thank you very much. Thank you.
Sir, kindly share your PPT.
Okay, yeah. I will
Sir?
give the I actually give the PPT to the